So now I'm going through question 1117B. I'm going to calculate the Cohen's d, estimated Cohen's d, the R squared, and a 90% confidence interval so that you can see what the influence of changing the standard deviation of the difference scores, what influence that has on these effect size measures. So estimated d, md minus mu d divided by your standard deviation of the difference scores. So 3 subtract 0. Our standard deviation of difference scores is now 12 though. So 3 divided by 12 is 0.25. Okay. This is a small effect size. When the standard deviation was 4, the Cohen's the estimated Cohen's d was 0.375. When the standard deviation was increased, Cohen's d decreased, and it went from 0.375, a medium effect, down to 0.25, a small effect. Okay. No, it didn't go from 0.375. Sorry, I misspoke because I was thinking like 0.375. That's a small effect because small is 0.2, medium is 0.5, large is 0.8. When Cohen's d was, when the standard deviation was 4, Cohen's d was 0.75, which was a medium effect. So it was 0.75, we increased the standard deviation of the difference scores and it decreases to 0.25, which is now a small effect. The comparisons are easier when everything's still on the board. R squared, t squared divided by t squared plus your degrees of freedom. When the standard deviation was 12, RT was 1. So 1 squared divided by 1 squared plus our degrees of freedom stayed the same as 15. So 1 divided by 16 . 0.0625. When our standard deviation was 4, R squared was 0.375, which was a large effect. When our standard deviation increased, the t decreased, and our R squared followed suit. The R squared decreased. And this is a small effect. The cutoff for a medium effect of R squared is 0.09. So this is a small effect. Now a 90% confidence interval. For the 90% confidence interval, mu d equals md plus or minus t times the estimated standard error. MD didn't change. Your t for your confidence interval is based on the percent confidence you want, which we didn't change, and it's based on your degrees of freedom, which didn't change. So the t that we want here is plus or minus 1.753, so that didn't change. Our estimated standard error did change. I suppose I can put MD in there. So 3 plus or minus Now, 1.753 times 3 plus or minus 5.26. So 3 subtract 5.26 is negative 2.26. And then 3 plus 5.26 is 8.26. So our confidence interval, when we increase the standard deviation, our confidence interval increased. So I'm going to put those numbers over here because I want to show you what this looks like. When I say that the width increased, what does that mean? So when we had 17A with a 90% confidence interval, I'm going to need to that look approximately the same. Push me off here. Close enough. All right. 17B with a 90% confidence interval. So they're centered on the same number. Because the mean, they're centered on the mean difference, and the mean difference didn't change. What did change was the standard deviation. When the standard deviation was 4, then these two boundaries, we'll say here, 1.247 and 4.753. When the standard deviation of the difference scores was increased to 12, these two boundaries, this width became wider. The interval became wider, negative 2.26 and positive over here, 8.26. I'm supposed to draw it to scale. It's more like they went out here. Oh, just a moment. So they went out to here. And so they went out here. Okay? So the width of the confidence interval increased.